Workshop theory and practice course facilitates the learning of the students about workshop tools and machines.
It also provides important practices and techniques that are relevant in order to utilize the knowledge and perform the machine and tools at a professional degree.
I am Jenny Tinori.
I am Nelj Itimanil.
I am Shainali Tolentino.
I'm Sofia Lorraine A. Velasco.
I am JD Villadrey.
I am Eljan Rupert Villeta.
And this is Module 8, Planer, Shaper, and Milling Machine. In this chapter, we will be focusing on the three of the important machines in metalworking, such as planer, shaper, and milling machine. These machines are fundamental in the production of complex components, precise surface shaping, and molding to achieve the specific dimensions and shapes indicated on your blueprints.
Throughout this module, students will gain an understanding of each of the machines, including their important components, operating principles, practical applications, and purpose that will support them in the field.
It is an essential step towards mastering these machines is to gain knowledge and understanding the fundamental techniques necessary. Students will find this module to have valuable insights and guidance for their engineering endeavor.
At this point, I and Ms. Tenorio will be discussing about shapers. So do you have any idea what a shaper is? Well then, if none, here's what a shaper is. A shaper is used as a reciprocating cutting tool that has flat and curved surfaces, keyways, slots, and irregular shapes. This may be slow, but it is reliable and having satisfactory results. These are still used in some industries, but are not as common given the rise of CNC machines.
Similar to any other machine, shaper machines vary on types. These include the crank type shaper machine, geared type shaper machine, and hydraulic shaper machine. Crank type shapers are used to hold workpieces on the table. Geared type shapers has a ram that is reciprocating. This is vital as it affected by reciprocating motion by the rack, pinion, and rack tit. Lastly, a hydraulic shaper machine utilizes the hydraulic mechanism to drive the ram, giving cutting speed and force. These are quite to use yet reliable ones.
Before operating a shaper, an operator must be fully knowledgeable of its parts. Listed are the parts of a shaper. The base supports the weight of the machine and absorbs the cutting forces. The column contains the drive mechanism and supports the ram and table. The cross rail holds the saddle and table for lateral movement. The table holds the workpiece. This can be rotated and changed levels. The ram carries the tool head, while the tool head holds the cutting tool and functions for any direction of relief movement.
There are also different shaper machine operations. These operations control various surfaces like horizontal, vertical, angular, and irregular surfaces. Machining horizontal surfaces create flat and leveled surfaces that are held in a vise. To perform horizontal machining on a shaper, first clamp the workpiece to the machine table or vise. Second, position the tool at an optimal inclination and height above the workpiece. Third, calibrate the depth of cut and set the machine in motion. Fourth, adjust the stroke's position so that the tool advances 12 to 15 mm before commencing the shaping process. Fifth, engage power feed once cutting commences. Sixth, inspect the workpiece and repeat the procedure if further material removal is necessary. Seventh, secure the tool vertically with the cutting edge slightly away from the workpiece to avoid digging in. Eighth, avoid excessive projection of the cutting edge below the tool holder. Lastly, do not extend the vertical slide of the tool head too far below the ram to avoid compromising tool integrity and chatter. For additional tips, use a sharp tool with the correct rake angle for the material being machined. Use a coolant to lubricate the tool and workpiece and reduce friction. Take light cuts to avoid overheating the tool and workpiece. Monitor the machining process closely and make adjustments as needed. Machining vertical surfaces are for removal of materials from a workpiece by reciprocating cutting tools up and down and create vertical surfaces as well. Steps: first, align and secure workpiece. Second, select and mount side cutting tool. Third, adjust length and stroke position. Fourth, set vertical slide to 0 position. Fifth, engage down feed screw and apply 0.25 mm feed at the end of each return stroke. Sixth, repeat step 5 and 4 for roughing and finishing cuts.
Angular machining is for the tool head to achieve a desired angle. It is done by adjusting the apron to minimize the tool from interfering with the workpieces. A universal shaper may also be used to perform this process. For irregular surfaces like concave, convex, and blended shapes, a round nose cutting tool is used.
In addition, there are also cutting slots and keyways to be used on a shaper. Machining of external keyways. First, use a square nose tool similar to a parting tool. Second, drill a hole at the blind end of the keyway, slightly larger in diameter than the keyway. Third, adjust the stroke so that it ends precisely at the clearance hole. Fourth, reduce the cutting speed. Machining internal keyways. First, hold the tool on a special tool holder so the tool post will not hit the work at the end of the stroke. Second, lock the clapper block in the clapper box to prevent the tool from lifting during the return stroke. Third, lubricate the work to prevent tool wear.
It is important to take note that there are several shaper machine mechanisms. Rotational motion can be transformed back and forth that is given to the round. In most shaper, a quick return mechanism is present. For this quick return mechanism, there are various methods: crank and slotted link mechanism, Whitworth quick mechanism, hydraulic shaper mechanism, automatic table feeding mechanism. Crank and slotted link mechanism is used to convert rotational motion to linear motion, involving crankshaft and slotted link. This is done as the rotation of crankshaft moves the link back and forth, affecting the ram to be in linear motion.
The Whitworth quick return mechanism is used to achieve reciprocating motion. The links allow the ram to move on various speeds and strokes, obtaining a faster return motion.
For hydraulic shaper machines, the piston is driven by a hydraulic pump to move the ram forward and backward. This works like any hydraulic mechanism.
Last mechanism is the automatic table feeding mechanism. This uses a ratchet wheel to feed the table during cutting operations. It is fixed to a screw linked to the table. It turns in sync, driving the table in retraction for accurate and correct machining.
A planer is a machine tool designed to create precise cloth surfaces and cut slots with efficiency. A planer in any form is used to machine flat surfaces, horizontal and vertical angular.
The planer compared to a shaper is larger in size. To operate a planer, the workpiece slots move between points during operation, whereas the workpiece slots remain stationary in the shaper. It employs a single point cutting tool. It is almost similar to a shaper machine, but a planer can handle much larger work and heavier cuts can be taken. This machine can be credited to general bend thumb.
There are different types of planer: standard or double column planer machine, open side type planer machine, bit planer machine, edge or plate type planer, and divided table planer. Standard or double column planer is the most widely used type of planer machine. It is characterized by a long, heavy base on which a table reciprocates an accurate guideways. An open side type has housing only on one side of the base. The cross rail is suspended from the housing as a cantilever. This feature allows the large and wide workpiece to be clamped on the table and reciprocated over the cutting tool.
A pit planer, meanwhile, are suitable for work that are too large for standard planers. This design saves on floor space. The length of the bed required for this type of planer is a little over the length of the table. An edge planer is a way different from an ordinary planer, as its primary function is for squaring and beveling the edges of steel plates, as well as different pressure vessels and shipbuilding works. Lastly, the divided table planer that has two tables. This may be reciprocated separately or joined. This is a time saver in terms of setting up to work.
Presented on your screens are the common types of planer. Aside from those, you may notice that some parts are labeled. These are those essential parts. Let's get to it one by one. Looking the planer, the common parts of a planer are the bed, column, cross rail, table, tool head, and table drive. The bed is the heavy and rigid casting. This supports the columns and the moving parts of the machine. The columns, or known as uprights, are vertical structures that are fastened on the sides of the bed. Their primary function is to absorb forces due to cutting. The cross rail, meanwhile, is another rigid casting. This gives guides for the transverse of the saddle. This also controls the feed rod and screw.
Aside from those, table is another part of the planer. This is a broad surface for holding the work. This has T-slots for bolting and holes for stops. The tool head is similar to a shaper's tool head, which has a feed screw to move it. Lastly is the table drive. This is from one of the three methods like rock and spur gears, spiral, rock and crank.
Cutting tools used on the planer are similar to those used on the lathe. However, the planer is used to machine flat surfaces, while circular surfaces are machined in lathe operations.
In addition, there are also planing operations for various surfaces. This include for horizontal surfaces, angular surfaces, curved surfaces, and helix ones.
Planing horizontal surfaces is to use the machine to level and smooth flat surfaces, commonly on wood or metal. Planing at an angle means using the machine for angled surfaces on a workpiece.
Planing curved surfaces can be used for shaping components, especially those used for ergonomics and decorations. Planing a helix is used on metal and woodworks where grooves and threads are needed.
Last machine that we will be tackling today is the milling machine. I know most of you don't have a thorough idea of what a milling machine is. That is why I, together with Mr. J.V. Villa del Rey and Ms. Nadia de Manil, will be discussing milling machines, operations, and heads. A milling machine is basically a power-driven machine which functions on removing a material from the workpiece. This machine is widely used in manufacturing processes for a variety of shapes and pictures, which are done through the rotation of multiple tooth cutting tools.
And using this machine, one should always practice safety precaution. Milling machines are sharp cutting tools and may pose serious injuries. Yet, despite these hazards, milling machines are widely utilized with its array of function in the modern day of manufacturing. An operator must be knowledgeable of the parts of a milling machine. This includes the base, the overarm, the spindle, the knee, the table, the saddle, and the column. The base provides support for the other components of the machine. The overarm is the horizontal beam that supports the spindle head. The spindle is the rotating shaft that holds the milling cutter. The knee is the movable component that supports the table. The table, it is the surface that supports the workpiece and can be moved on both axes to feed the workpiece. The saddle is the movable member that is attached to the knee and supports the table. Lastly, the column, it is a vertical member that supports the spindle head and knee.
With a lot of functions and workpieces to work on, we should also take note of the various types of milling machine. These machines include knee and column, plain milling machine, universal milling machine, and vertical milling machine. The knee and column milling machine is the most common type of milling machine, named from the knee and the column structure. A plain milling machine, meanwhile, or a slab milling machine, or a surface milling machine, is utilized on flat surfaces and large workpieces. The universal milling machine, on the other hand, from its name, are machines that can perform any task from flat surfaces to complex shapes. Lastly, vertical milling machine is a vertical-oriented spindle. To adjust the depth, the spindle can be changed on levels and move the workpieces on both X and Y axis.
Aside from knowing the machine, an operator must also be knowledgeable on the safety precautions. This is to avoid any accident or damage on the machine itself.
Here are some suggestions from Brown and Sharp Manufacturing Company. Anticipate the actions to take place before moving the operating lever. Never play the control levers or carelessly turn the handles while the machine is stationary. Do not lean against or put hands on a moving component. If necessary to do so, identify the direction in which the component is moving. Ensure that the work, if held securely in the fixture, and the holding member is fastened to the machine table before performing cuts. Remove chips with suitable instruments and never with bare hands and fingers. Study the milling machine thoroughly to devise accurate plans and actions when certain emergencies arise. Keep distance with the milling cutter. Avoid touching the cutter even if it is stationary. If suggested to do so, do it carefully.
Before running the machine completely, preliminary operations should be done on the milling machine. This includes cleaning the machine, oiling the machine, and mounting the workpiece. The importance of a clean machine holds much significance and cannot be emphasized too strongly. Machine's accuracy and durability depends on the level of maintenance and cleaning an operator is doing. It is suggested that milling machines are cleaned regularly before and after usage.
Oiling machines cuts damages on the milling machine. Few drops applied regularly is very much needed to safeguard the mechanical condition of the milling machine. Modern machines are equipped with automatic lubricating systems, which should be maintained in its finest state for better function.
Before operating the milling machine, securely positioning the vise to the table is needed. There are various techniques on mounting the workpieces. These include on the table, in a chuck, on an arbor, between tenters, on fixtures, milling machine vise, and clamping devices. There are also certain methods on aligning the vise straws with the column, which are to the indicator, parallels, and with a square.
Aside from preliminary operations mentioned above, properly selecting a milling cutter that is suitable on the job to be done obtain great results. Common milling cutters and their applications. Double angle cutter, used for fluting taps, reamers, and so on. End mill, suited for surface milling, profiling, slotting, and so on. Fly cutter, can be used to mill intricate shapes that do not warrant the expense of form cutters. Form cutters, used to cut curved or irregular surfaces, also for fluting tops, reamers, twist drills, and so on. Half side cutter, used for faced milling or in pairs for straddle milling. Helical cutter, especially adapted for thin work or intermittent cuts where the amount of slack to be removed varies. It is not a general purpose cutter. This cutter is erroneously called a spiral cutter. Inserted tooth cutter, characterized by long life, it is used for heavy-duty face and side milling work. Interlocking side cutters, designed to maintain an exact width for milling slots. Nicked cutters, suited for making deep cuts as in roughing work. Plane cutters, used to mill a flat surface parallel to its axis. Side cutter, suitable for slotting operations. Single angle cutter, chiefly used to cut milling machine cutter teeth. Slitting cutter, used to cut deep slots and to cut off stock. Slotting cutter, used to mill shadow slots, such as screwhead slots.
Cutters must also be sharpened to attain satisfactory results. A dull cutter does not last long compared to a cutter in proper condition. Angles are taken into consideration as well as clearance angles of the cutters. Presented are the suggested clearance angles of cutters based from the Cincinnati Milacron Company.
Also be mounted properly to avoid any accident. Mounting this depends on the length of the arbor or the cutter and the support bearings. Cutter rotation should also be considered. It may be conventional, whereas the feed is against the cutter rotation, or climb milling where both feed and the cutter rotate in the same direction.
The speed of a milling cutter is influenced by the amount of material removed per minute and the relationship between the depth of the cut and the feed. A shallower depth and higher feed allow for a faster speed compared to a deeper cut and a lower feed, although the material removed per minute may remain the same. Now, the rigidity of the machine and the workpiece fissure also affect the cutter speed.
Feeds, meanwhile, the feed rate in milling represents how quickly the work moves past the cutter and is typically measured in inches per minute. In production, the general practice is to maximize the feed that the machine and work can handle. Determining the starting point for the feed rate can be challenging.
Different fluids and compressed air serve to dissipate heat during metal machining, with the choice of coolant contingent on the material being worked. Cast iron, milled at typical speeds and feeds, doesn't overheat milling cutters and should not be used with a liquid coolant, as it creates a sticky mess. Different fluids and compressed air serve to dissipate heat during metal machining, with the choice of coolant contingent on the material being worked. Cast iron, milled at a typical speed and feeds, doesn't overheat milling cutters and should not be used with a liquid coolant, as it creates a sticky mass when mixed with cast iron chips.
Moving on to the milling dividing heads, which are used to rotate a piece of work through angles, commonly on dividing a circle to equal parts. These heads are classified as plane, universal, and helical.
The worm wheel, with 40 teeth, is keyed to the spindle for core rotation, on which the worm operates with the worm wheel at a 40:1 gear ratio. The index plate contains various rows of holes with different hole counts, easily swappable for desired spacing. The index pin on the crank attached to the worm shaft can be placed in any hole. And lastly, the sector has adjustable radial arms secured with a clamping screw for setting desired angles. Next is the universal type. What sets a universal dividing head apart from a plain dividing head is its versatility and additional features. A universal dividing head stands out with its versatility and swiveling mechanism for cutting gears, flutes, and various tasks at different angles, making it ideal for complex operations.
Lastly, moving on to the helical dividing head. It allows precise and controlled rotation of the workpiece at a constant angle, facilitating the cutting of helical patterns like threads and grooves. It differs from plain and universal heads by connecting the spindle to the table leg screw, enabling simultaneous longitudinal movement and rotation.
We also have the dividing head and driving mechanism. With this, the Cincinnati Milacron Company, an American machine tool builder, manufactures dividing heads in 10-inch, 12-inch, and 14-inch sizes, which are used extensively in milling spiral and helical gears, cams, and so on. Accordingly, there are two types of driving mechanisms that can be used on all heads. First, the enclosed standard lead driving mechanism, which is for standard equipment on universal knee and column machines and available for plane and vertical machines. And second, the short and long lead attachment for extra equipment. It is also important to note that there exists such an instruction for setting up of dividing heads and driving mechanisms that are to be followed in order. And that wraps up our brief discussion of Module 8, where we delved onto the concept of planer, shaper, and the milling machine. Thank you for listening.